Hello, my Algebra 2 students. Today is day 8, so we are talking about completing the square, which is a process you learned back in possibly Algebra 1. I know you were supposed to do it in geometry, not sure how that went. But before we hop into that, I want to show you why we're doing it. So as a little warm-up here, I want to compare these two functions. So if we have f of x equaling x squared, versus g of x equaling x plus 2 squared and then minus 3. So if we think about them graphically, well, we know it's a parabola because we're in a quadratic function. So the basic quadratic, this would be a parabola right here, where the vertex is directly at 0, 0, opening up. So if we kind of do some basics here, versus this guy. I want you to think back to our transformations unit. Whew, going way back. So if we have plus 2 on the inside, minus 3 on the outside, what I'm hoping that you're remembering is that this would be a translation, or sometimes we just called it a shift. Right? If it's minus on the inside, that's actually going to, or excuse me, if it's plus on the inside, that's going to move us to the left. If it had been minus, it would go to the right. So the left 2. Minus 3 on the outside, that's going to shift us down 3. Now, when I say shift us, I mean the parent function. So that's what this guy is. So if we think about that parent function, the vertex is going to move from 0, 0, left 2, and then down 1, 2, 3. So maybe down here. Maybe I should extend that a little. All right. So that's going to be the new vertex. And then the parabola would still open up. We didn't flip it over. We didn't do anything else super crazy to it. But the vertex itself would move to -2, -3. Right? So that's important to note that just by looking at the equation in this form, we can actually figure out where the vertex is and then have an idea of what the graph is going to look like. Right? So when we start talking about completing the square, you'll see why that becomes so important. Right? So our goal for today is to complete the square, or let's convert quadratic equations in the form of y equals ax squared plus bx plus c into what this is known as is vertex form. So into vertex form, which is going to look like this: y equals a times x minus h squared plus k, right, by completing the square. Make sure I'm not off the page there. I'm not. All right, cool. So that means I need to remind you, okay, how the heck do we complete the square? Like, what does that even mean? All right. So let's give ourselves an example to work with. That always seems to make things easier. So first equation I'm going to give you is y equals x squared plus 4x plus 1. Right? So when I said convert it from this form, this is called standard form. So we're in standard form right now. Feel free to add that up here if you like. So that's that ax squared plus b, oh my goodness, bx plus c. Ooh, this is what happens when I'm at home and there's nobody to yell at me and tell me that I've missed things. There we go. Bx plus c. That's important. Okay, so that means this is in the form of y equals ax squared plus bx plus c. All right. So then we can easily see, like right now, the a is 1, the b is a 4, the c is a 1. Okay. What we are going to do to complete the square and change it into this format is follow the steps that we'll write alongside as we go. So step number 1, right, is that we want to move, excuse me, move the constant to the other side to get the x's alone. So get the x terms alone. All right. So all that means we're just going to quick subtract the 1 on over. So we're going to get y minus 1 and then equals x squared plus 4x by itself. So there's the first part, right? Here is how we get it into this form. And this is the actual completing the square step. What we have to do is you have to figure out what can I add over here. So I'm going to grab a different color. If you have a different pen, that would be awesome. We have to figure out what are we going to add here, and then we'll balance it by adding it on the left side as well. That'll make this a trinomial that's factorable into two equal factors. Right? So if you think about when you're multiplying through, like in a box method, to have it add up to this and then multiply to that last value, to make this work perfectly, we're going to take what that middle term is, we're going to chop it in half and then square it. And you'll see how that's going to work nicely. So I'm going to write it down as take the b term, divide it by 2, square it, and then add that to both sides of the equation. Okay. So in this case, my b term, that's this guy, we're going to cut it in half. So that's this, which gives me 2, and then square it, which will give me 4. That's what I'm going to add in this blank spot here. And then to balance it, you add it to the other side. Because if I just add it to the one side, now I'm changing the equation. If I add it to both, I'm keeping the equation balanced. All right, what we have now done, right, is we have now created a quadratic that should be factorable. So step 3 is to factor, I'm going to call it the x side of the equation. All right, so let's do it. So if I take this and I factor it, well, what adds to 4 and multiplies to 4? Well, x plus 2 and x plus 2, right? On the left side, all I'm going to do is just combine my like terms as I bring it down. So minus 1 plus 4, that'll be plus 3. All right, so a little note over here. You should have 2 equal factors here. So if we did it right, it should be the same factor twice. So the x plus 2 and the x plus 2, which means we can write it as whatever that factor is squared. So let's do that. That means we have x plus 2 quantity squared. Okay, we're getting really close to the format that we wanted in. At this point, all I want, if I come back up here and look at my goal, is I have something squared and then plus k. Well, that means that I'm going to get the y alone and just move that on over. That'll be the plus k piece of it. So step 4 is we're going to get the y alone. Right? So whatever's over there with y, in this case, the plus 3, we're just going to subtract it over. And so we end up with y equals x plus 2 squared, and then minus 3. This is now in vertex form. And you might even recognize that's the exact question that we just looked at up top for our little warm-up. Okay. So now it's in vertex form. Right? And now vertex form, I'm going to write it right beneath it. We wrote it as a times x minus h squared plus k. Well, if there is no a there that we're seeing, then we know a is just 1. That's fine. Right? The h would be a negative 2, and then the k would be negative 3. So when it's in this format, we can think of it as a translation where we go left 2 and down 3 to get the vertex, or we can always think of the vertex as being a coordinate point that are the hk values themselves. So in this case, it would be a vertex of negative 2, negative 3, which matches exactly what we just did above. All right. The first time through, it always looks a little funky. We're going to do it again, and hopefully it'll be a little smoother. It'll move a little faster this next time. All right, guys, let's try example 2. So this one's a little bit different because the completing the square process only works if that value is a 1, all right? So write yourself this little note that completing the square only works when the a value is 1. So to start this one, you actually have to eliminate the 2 by dividing it out to the other side. So we're actually going to start with dividing the 2 out. All right, now sometimes teachers will factor it out. There's multiple ways to do it. I kind of like to divide it and just get it out of the way. So we're going to divide everything here by 2. So that means on the left-hand side, I have f of x over 2. And on the right-hand side, I now have x squared plus 2x and then plus 1/2. Don't be afraid of the fraction. It's perfectly fine. Now we get to run those steps. So step 1 that we wrote down was to move the constant over to the y side. So let's subtract that 1/2 on over. And so you end up with f of x over 2 minus 1/2, and then leave a little space here. And then equals, we got x squared plus 2x. All right, here comes the completing the square step. Remember, the b term, that's the coefficient on the x. So the b term here, you're going to take it, chop it in half, and square it. So 2 divided by 2 is just 1. 1 squared is 1. So I'm going to add 1 to the right-hand side, and then to balance the equation, add 1 to the left-hand side. What you should now have is a quadratic here that is factorable. So you can factor this guy by thinking about what adds up to 2 multiplies to 1. Well, that would just be x plus 1 and x plus 1. So nothing crazy there, which means I can rewrite this as x plus 1 quantity squared. All right, on the other side, let's just clean it up. Minus 1/2 plus 1 turns into really plus 1/2. So when I bring it down, I have f of x over 2 and then plus 1/2. All right, at this point, once you get it into the quantity squared, your job is to now get everything back on the same side with it. And so the f of x is alone, because f of x is the same as y. So what I would move first is the 1/2. So I'm going to subtract this back on over so that I get x plus 1 quantity squared minus 1/2. And then that equals f of x over 2. And then my last step, the fact that I have over 2, well, I want to move that. So I'm going to multiply both sides by 2. And when I do that over here, I have to multiply everything by 2. So the 2 cancels on the left-hand side so that I just get plain old f of x. And now on the right-hand side, I'm not allowed to distribute a 2 through a parenthesis that has a squared attached to it, because order of operations, I would need to square that out first and then multiply by 2. So it really just means I'm going to leave the 2 sitting in front of it. Whereas back here, when I multiply this piece by 2, well, 2 times 1/2, that just gives me minus 1. That is now my equation in vertex form. So vertex form is y equals, or in this case, f of x equals a, and then times x minus h squared plus k. So what that means is the vertex, remember, is just the hk part of it. So that would be the -1 here, which means you're shifting left 1, and then down 1. So the actual vertex for this problem would be -1, -1. What's the 2? Well, the 2 is a vertical stretch. So don't worry about that in terms of determining the vertex, but in terms of what the graph would look like, yeah, it'd be a lot narrower than a typical, like the parent form of the parabola. All right, let's try this again. Example 3. Now we should hopefully be getting the hang of this. So we've got y equals x squared minus 3, make it a plus 3x minus 4. All right, if you want to, feel free to pause the video and try it on your own. Otherwise, you can play it through with me. So there's no leading term to worry about. We're good there, which means first step, move that constant to the other side. So that's going to make it y plus 4, and then equals x squared plus 3x. And if you think of it, leave yourself that little space there, all right? Now, when we look at the b term this time is a 3. So when I cut that in half, and then square it. That's going to give me 3 times 3 over 2 times 2, or 9/4. Let the fraction stay as a fraction. So add 9/4 here, and then add 9/4 here. Yes, technically it's 2.25, but I don't want to mess with that. I'm going to leave it as a fraction, right? So this is not typically something that we would try to factor. So in the case of like trying to figure out what the heck works here, well, if you think about it, what adds up to 3 would be 3/2 plus 3/2. What multiplies to give you the 9/4? Well, 3/2 times itself. So by doing this process over here, you actually figure out that what always goes in the parenthesis is just going to be x and then plus whatever the b over 2 is squared. We didn't really need the help last time because it was easy to do. But if there's one like this that's a little bit funky, then what you could do is take whatever b is divided by 2, that goes into both parentheses. So 3/2 plus 3/2 would give me 6/2, or 3. 3/2 times 3/2 gives you the 9/4 right there. All right. So that means I have x plus 3/2 quantity squared. On the other side, you can add this together on your calculator, or you could get a common denominator of 16/4 so that you could add it to 9/4. So you'd get y plus 25/4, and then we're almost there. Just bring it back over. So I'm going to have x plus 3/2 squared, and then subtract that 25/4 back to the other side. All right, so this is our vertex form right here. It means the vertex is a little messy this time. That's all right. That happens. So the vertex, it's the opposite sign here. So it would be negative 3/2, and then shifting down here. So minus 25/4. Now, if we actually typed this into the calculator and went and looked for that vertex, you wouldn't see these numbers pop up. You would see it as a decimal. So it would be negative 1.5. This would be negative 6.25. Right? So just to finish it out and kind of check one of these guys here so you can see it, I actually am going to grab my calculator and let's take a little look at it. So on my calculator, I'm going to go into my y equals and put in that original function right here. So if I go x squared and then plus 3x and then minus 4, I'm just going to go to zoom 6. So if I just zoom 6, you can kind of see. Maybe try on the, oh, maybe the light made it worse. All right, there's that parabola. So I can kind of spot where the vertex is. As a little reminder on the calculator, to calculate the vertex, it's either a minimum or a maximum point. And so in this case, it would be the minimum. So if I go to second, trace, and then choose minimum, I can let the calculator do some of the work here for me. All right, so slide on over. It's going to ask you for a left bound, right bound, and take a guess. We've done a little bit of this before in the year. So you've got the arrows pointing towards the center, and then the minimum comes out as negative 1.5. Mine is in change. It says negative 1.500002. So the calculator is just like a little off in its estimation, but then comma, negative 6.25. And that checks exactly what we have here. So that's actually a nice way to know my answer is right. A second way to do it would be to say, well, let's graph both of these. So I made that one y1. If I make this guy y2, I can go and in parentheses, x plus 3/2, close it up and square it, and then minus 25/4. If I graph them, there was the original parabola, and then you should start to see it trace over. It might be a little tough with the colors here in red, but basically what it did was trace directly over it because this equation and this equation are exactly the same. So there's a couple ways as we're doing the work that we can check and make sure that we are converting the equation correctly from here to here. We're not making a new equation. We are just rearranging what we have and coming up with an equivalent equation for that same parabola. All right. Thanks for watching, guys. Go answer that post-video question.